Yes, let's continue this. Now, we are comparing primary, secondary and tertiary amines regarding their basic character. And I have told you the basic character, that means tendency to accept a proton, will depend upon electron density available on nitrogen where proton is going to attack. Fine. Now, here we have one alkyl group. We know alkyl groups have plus I effect, that is electron donating groups. So these groups will tend to increase the electron density around nitrogen. Fine. So here also you have two R groups and here you have three R groups. So more R groups are there, more will be the electron density on the nitrogen. So you see, in case of tertiary you have more electron density around nitrogen. This shows that they are the most basic among them. Fine. So this is the comparison when the reaction takes place in the gaseous phase. So in gaseous phase we can say tertiary are more basic than secondary than primary, and all these three are more basic than ammonia. They are derivatives of ammonia which are more basic than ammonia. Fine. So this is one comparison in the gaseous phase when no water or no aqueous medium is there. Now the most interesting thing, that most of the reactions of the basic character of amines take place in aqueous medium. Fine. So let us discuss now what is the comparison, what is the experimental finding in aqueous medium. Right? In aqueous medium, that is reactions in water. Let's see what is the experimental finding. Here we have two cases. When methyl is present, methyl group is present, it is dimethylamine. This is secondary, is found to be more basic than methylamine, which is found to be more basic than tertiary amine, and all of them are more basic than ammonia. Fine. So you see here the comparison seems to be a little bit out of the general order. Secondary is more basic than primary and primary is more basic than tertiary in this particular case when methyl is present in amines. Fine. Then we have another case, another experimental finding. If methyl group is present, diethylamine, which is again secondary, is more basic than tertiary, than primary, and they all are more basic than ammonia. Fine. So we are going to explain this factor, that in aqueous medium what happens to their basic character, right? Usually the usual trend in gaseous phase we have found on the basis of only I effect, that is availability of electron density on nitrogen. The effect is tertiary more basic than secondary, than primary, and then ammonia. But what happens in the aqueous phase? In aqueous phase we know definitely availability of lone pair on nitrogen will matter about the basic character, that is due to plus I effect. Due to plus I effect, that is electron donating effect of plus R group, R group. But at the same time some other factors also play their important role here. That is, one factor is hydrogen bonding, which the cation will form once amines gain a proton. I will discuss it later. And third related effect is a steric effect, on which tendency to form hydrogen bonding also depends. Fine. So these three factors are there and their combined effect will decide the above two cases. Fine. So let's discuss what are these effects and how such findings will be explained. Now let me take first the primary. we have a primary amine. In primary amine, let's discuss the tendency to gain proton. It will be there, and as a result we know here aqueous medium is there. Fine. So the cation formed will be this. As this cation is formed in water, so water molecule will surround this cation through hydrogen bonding, and you see in this case there are 3 NH bonds. So there will be a greater tendency for H bonding with water molecule. I'm writing water like OH2. Fine. Partial positive, partial negative. Fine. So a larger extent of H bonding is found in case of this ion which is formed from primary amine. Let's consider secondary amine here, where 2 R groups are present. In this case, their basic nature, that is gain of proton by nitrogen, the cation formed will be this, and there are 2 NH bonds, so extent of hydrogen bonding is little bit reduced. Fine, due to presence of only 2 NH bonds, right? Here it is positive charge on nitrogen. So in aqueous medium we will find that the stability of this cation which is formed in water also matters, also decide that what is the tendency of the amine to gain a proton. Let's see in the case of tertiary amine. In case of tertiary amine, after gain of H+, let's see what is the situation of the ion formed in water. This ion will now have only 1 NH bond, and as a result there is least extent of H bonding in this case. Fine. So this is your secondary amine, this is your tertiary amine, and you see while moving from secondary towards tertiary, the extent of H bonding decreases. As H bonding decreases, you can say that the ion formed is less hydrated, less attracted by water as we move from this ion to this ion, right? As we move in this direction, that is ion formed by primary, secondary and tertiary, right? So now you consider here on this side there is attack of H positive on nitrogen, that is will be decided by plus I effect only, right? So if you see, the availability of lone pair on nitrogen will be highest in this case due to 3 R groups present. Therefore, which is less in the case of secondary, only 2 R groups are present, and very less tendency to gain H positive when 1 R group is present. So if we decide only on the basis of I effect, that is availability of electron density on nitrogen, then we'll see the order seems to be like this. Tertiary